Okay, this is Matgen110. We're looking at 8.3, the last section that we're going to cover in Chapter 8. So let's take a look. We're looking at like terms and unlike terms with radical equations. So let's see here. In order to be like terms, they have to be the exact same root with the exact same variables or numbers. So look, this is the square root of x, that is the cube root of x, so that is unlike terms. 2a square roots of 6 and 2 square roots of 6a. See, the a isn't under the square root sign in here, and it is there, so those are unlike terms. 4 fifth roots of x squared y and negative 1 fifth roots of x squared y. Finally, like terms. So those we could add together. And speaking of adding together, look, we have 8 square roots of 3 plus 9 square roots of 3. So we make that 17 square roots of 3. Now, it is very important that you do not change what's under the square root sign, for the same reason that way back in the olden days when we did 5x plus 6x, we just made it 11x. We didn't change the variable at all. It didn't change the power, and we didn't change anything about it. It just stayed x. Same thing going on here. 8 square roots of 3 plus 9 square roots of 3. You just basically do the 8 plus 9, that's 17, and then you tack on the square root of 3. 5 square roots of x plus 3 square roots of x minus 2 square roots of x. That's 8 minus 2, that's 6 square roots of x. 2 square roots of 5 plus 5 square roots of 2. That's a trick. Those are unlike terms. So we can't really do anything with that. It just stays 2 square roots of 5 plus 5 square roots of 2. 7 square roots of 5 minus 9 square roots of 5 minus, remember when there's nothing there, there's a 1 there. So we have 7 minus 9 is negative 2 square roots of 5 minus 1 square root of 5. So a negative 2 and a negative 1 is negative 3 square roots of 5. All right. Okay, let's continue. So we're on the Chapter 8 note packet, and we're on page 5. So number 6, we're going to actually call back to what we did in the last section. In fact, this whole section we are. 5 plus 3/4. Okay, so that means we're going to simplify these. So look, we're going to break this down, we'll use black, into perfects and leftovers. Perfect, square root of 4, leftover, square root of 3. And the 5 is still in front, 5 times that times that. So we've broken down the square root of 12 into the square root of 4 times the square root of 3. Now, you don't want to do 6 and 2. 6 isn't perfect, neither is 2. One of them has to be a perfect square when you break them down to simplest radical form. All right, this one is 7. Again, there's a perfect in there, that's 9. And then there's a leftover, that's 3. So we have 7 times the square root of 9 times 3. So now let's work this. We have 5 times 2 times the square root of 3 minus 7 times 3 times the square root of 3. So that is 10 square roots of 3 minus 21 square roots of 3. So initially when we started, it looked like they were unlike terms. But then after we simplified it, they turned out to be like terms. And so we could do 10 square roots of 3 minus 21 square roots of 3. 10 minus 21 is negative 11 square roots of 3. And that's our answer. Let's do this one. We got 2/3 times perfects and leftovers. That's 9 and 5 plus 3/4 times perfects and leftovers. And now you could take a hint from this. This one was relatively easy to find. The 9 times 5 is 45. But this one, 80, is a little tougher. So try the leftover. Try the square root of 5. If you take 80 divided by 5 on your calculator, you will get 16, which is a perfect square. All right. So now let's do what we did there. We evaluated the square root, so we can evaluate that. So 2/3 times 3 times the square root of 5 plus 3/4 times 4 times the square root of 5. Ooh, look at what happens. We got 3 over 1 and 2/3, so that's, the 3's are going to cancel, the 4's are going to cancel. We're going to get just 2 square roots of 5 plus 3 square roots of 5. That is 5 square roots of 5. All right. Let's do another couple. Number 8 is 3x squared square roots of 18 plus x square roots of 8x squared. So let's do that. We can do perfects and leftovers. So the perfect is 9, leftover is 2, and we still have 3x squared times that, plus x. The perfect is 4x squared. The leftover is just 2. So check it out. We get 3x squared times 3 times the square root of 2 plus x times 2x times the square root of 2. So 3x squared times 3 is 9x squared square roots of 2 plus 2x squared square roots of 2. That is 9 plus 2 is 11. X squared square roots of 2. All right. And then number 9, we can squeak in. Number 9 is pretty easy because it's all square roots of 14 already. 1.2 square root of 14 minus 4.5 square root of 14 plus 2.1 square root of 14. And so all you're doing is 1.2 minus 4.5 plus 2.1. You click that into your calculator, hit enter, it'll kick out negative 1.2, and then just tack on the square root of 14. So that was really just a calculator problem. Let's do the next two on this page. So that is number 10 is 5 square roots of n to the 7th minus 8n squared square roots of n cubed. And number 11, square root of 28 plus 2 square roots of 16 minus the square root of 63. All right. So perfects and leftovers. We've got perfect here is going to be n to the 6th. Leftover is just going to be the square root of n. That's times still 8n squared. Perfect, square root of n squared. Leftover, just the square root of n. So let's see. When we take the square root of something to a power, basically we just divide that power by 2. So 6 divided by 2 is 3. So this is 5n to the third square root of n minus 8. Let's see, we have n squared times n, right? The square root of n squared is n, so n squared times n is n to the third square root of n. So, like terms. So 5 minus 8, negative 3n cubed square roots of n. Let's look at 11. I don't think all of those are going to work. Let's see. What do we have there? 4, the square root of 4. And then the leftover is the square root of 7. Plus 2. Well, the square root of 16 is perfect, so you just do it. It's times 4. Minus 9 is perfect. And 7 is the leftover. So let's see, we have 2 square roots of 7 plus just regular 8 minus 3 square roots of 7. So we can actually put those two together. Those are like terms. So here, let's write the 8 first and then do plus 2 square roots of 7 minus 3 square roots of 7. And when we combine those, we get 8. That's negative 1, but don't put the 1 on it. Just call it the square root of 7. Don't put the 1 there. I know for variables, I said I don't care if you put the 1 there, 1x, it's fine. But with these, don't put a 1 in front of the square root. That's a big no-no. All right. And then let's get the next page. We got a couple of word problems. Twice the square root of 6 plus the square root of 6. Oh, just interpret that. So twice the square root of 6, 2 square roots of 6, plus the square root of 6. So now remember there is a 1 there. We never write it there, but there's a 1 there. So 2 plus 1, that's 3 square roots of 6. All right, let's look at 13. Oh, I guess we'll do 13 over here. 13 is find the exact perimeter whose width is the square root of 32 and whose length is the square root of 8. Oh, I guess they got length and width mixed up. Length is always the bigger one. So look, this is the square root of 32. This is the square root of 8. So if we're going to add around the outside, square root of 32, square root of 8, look at what we have. We have the square root of 8 plus the square root of 8, that's 2 square roots of 8, plus the square root of 32 plus the square root of 32 is 2 square roots of 32. And now we can do perfects and leftovers. Perfect is 4, leftover is 2. Still get that 2 there, 2 times, and 2 times. Perfect is, well, the leftover is 2. The perfect is 16. So look at what happens. We got 2 times the square root of 2 plus 2 times 4 times the square root of 2. So that is 4 square roots of 2 plus 8 square roots of 2, which is 12 square roots of 2. That's our answer. All right. And then let's do 14. Oh, I think 14 was on the online, and that's why it's on Connect Math like this. So the slope, remember, is the change in y over the change in x. And so given that point, you do 8 square roots of 5 minus 4 square roots of 5 over 1 minus 3. So that ends up to be 8 square roots of 5 minus 4 square roots of 5 is 4 square roots of 5 over negative 2. Oh, and then we can reduce it again because look, 4 divided by negative 2 is negative 2. So we get negative 2 square roots of 5. That's our answer for that one. And there's a weird one like that on Connect Math. And then the last one here, let's just erase number 10 here, is they just give you an equation. and you pop in the time, so 2 seconds, and that's 24 square roots of 2. But in the real world, we usually don't say 24 square roots of 2. They want you to do it on your calculator. That's 33.9411255. And so, again, we don't even answer like that. We say, oh, you kicked the soccer ball about 34 meters. We must be in Europe. 34 meters. Yeah, it's a soccer ball. All right. So that ends chapter 8. We're only doing 8.1, 8.2, and 8.3.